Hi, everyone. Welcome back to the Hack Summit. We are joined here by Orion Henry, who is the co-founder of Heroku and designed the tech infrastructure for Heroku, and is a big fan of Ruby. He's a Rubyist, but also uses Erlang and Go. Previously, he was the CTO of Trust Commerce. He was the director of BitScribe and the principal architect for Salesforce.com. He also graduated from the prestigious Y Combinator incubator and graduated from the UC San Diego School. So, Orion, thank you so much for being here today. It's a real pleasure to have you.
My pleasure. Thank you.
Great. So what's going to be different about this session is the previous session was a fireside chat between myself and Brian Fox. Here with Orion, Orion's actually going to be delivering a presentation to you guys and sharing his screen and his slides. And so after the presentation, we'll be taking audience questions. But during the presentation, we may poll the audience, and you can feel free to ask questions, and they'll be queued up for after Orion's talk. So Orion, how's that sound to you?
Sounds great.
Great. And Orion, do you want to give us a little quick information about your background, like just about kind of how you learned to program and what you're passionate about these days, just that we get to know you a little bit first prior to the presentation?
Sure. Yeah. Actually, my first 6 or 7 slides is like this hyper condensed version of the Heroku story. So I'll get to give you a little bit of that during the presentation. But it's like, how did I learn to program? Very similar story to most people I run into, which was like, I was 11, I had access to a computer, but I couldn't afford games, so I wanted to write my own. And that desperation to feed my desire to goof around was the carrot on the end of the stick that forced me to learn to program. And by the time I ended up in college, and I didn't want to be a hacker. I didn't want to be a coder because it was a very unprestigious job at the time. So I signed up as an aerospace engineer, but then 2 years in realized I had not taken one aerospace class, but I was already halfway through a CS major just because I loved and was fascinated by all the CS classes that I was taking as electives. So, finished out as a CS major there, and then went on to work for 2 years as a software engineer before I realized I hated it and would rather starve to death as an entrepreneur than be fat and happy as someone's code mule. And actually discovered that you can do okay and feed yourself as an entrepreneur too. So that worked out well. Anyhow, yeah, let me get started.
That's a great story. By the way, I also became a programmer because of video games. So same exact story. In fact, I don't even know if I ever outgrew that desire. Actually, I actually started a game studio. So
that's awesome.
I should have learned a little bit earlier. That wasn't the best financial result. So
I've never actually made a game, post college. I never did sort of scratch the itch that got me started. But like I said, it was a carrot on the end of a stick. I never ate the carrot, but I sure did travel far.
Great. Okay, so Ryan, I'm going to go ahead and give you control of the camera here. You can feel free to share your screen, and I'll be here if you have any issues.
Sure.
Okay, feel free to take it away whenever you're ready.
Great. Yeah, let me just start in with my slides. Share screen. Okay, can you see my stuff? Ed? All right, well, let's start.
Yeah, you can see it. Looks great.
Great. Okay, so I titled this talk After the Cloud. I basically, I'm going to tell you a really, really quick version of sort of my role with cloud, like what we did with Heroku to kind of invent it, and sort of my growing thoughts on it and what could potentially replace it. So the cloud, this powerful enabling paradigm over the last decade, and what technology will succeed it. So I want to start off with story time. Basically, I think it'll provide better context if you guys know a little bit about the Heroku story and sort of some of the early days of cloud. It's funny to say early days because it was only a few years ago, but as with tech, everything moves quick. Anyways, Heroku, the really, really, really short version. This kind of deserves its own hour-long talk. It's a really fun story, but there's other things I want to talk about. So super fast. 2006, Amazon started AWS, and the enabling technology that allowed AWS to happen was virtualization. And with most of these big technological revolutions, there is some kind of enabling technology that comes along and sort of facilitates new things happening. In this case, virtualization, AWS. For the first time, people starting companies and wanting to have an array of servers didn't have to find themselves on the floor of the colo facility with a screwdriver at 2 in the morning trying to fix a blown power supply. They could use an API to summon up virtualized machines and build infrastructure on top of that. At the same time, my partners and I were reading obscure academic books about end user computing. My talk last year was about that, and we basically have this desire to see programming as a accessible tool for everybody. For that programming literacy isn't just a thing for hackers, but is something that at some point in the future is going to be as normal as knowing math and as knowing how to read and write, to just fully utilize these incredibly powerful, amazing computers that are around us and make our lives more productive. So we found that a lot of people were learning, a lot of non-programmers were starting to pick up Ruby. We went to like RubyConf in 2007 and found that lots and lots of people we meet were like non-programmers, glassblowers, and HR directors that had written Ruby apps, and everyone was getting stuck on the deployment story. So in 2007, we started Heroku sort of with these big ideas about facilitating end user computing, and put out the first version of our app. 2008, we entered Y Combinator. It was about 3 months later that we entered Y Combinator to with Heroku as our first product. Now, the product that we started off with was basically a web app you go to, you hit a button to say make an app, and then it generates a Rails app for you on the server, and then provides you with a in-browser code editor and an in-browser file browser, a database browser, log browser. You could edit the app and see the live feedback happening where you hit that little save button in the corner, and you could immediately reload and see that your app had changed. It was already running. And this was a lot of fun to build. There were no text editors in the browsers at the time, so we kind of had to roll our own. And there was no Docker, so we had to sort of figure out what the story was about running these Ruby processes with user code on the server. And this was a lot of fun. But early on, we noticed that we thought this was kind of an educational tool to kind of help people get started, but we noticed that a lot of people were bringing Ruby apps that they had written elsewhere and were uploading them through the upload interface and then just running their business on our code editing tool. And we were like, at first we're like, what the heck are these people doing? Why would they run a business on our code editing tool? And a less civilized mind would be upset at them for abusing our system, but we realized that actually this was a huge business opportunity. So we could turn this from an educational tool into this massive cloud thing that would serve potentially hundreds of thousands, or maybe hundreds or maybe thousands of apps, and ended up being hundreds of thousands and eventually millions of apps. So we sat down to design the architecture. We're like, man, this will be easy. We just client server, man. We got clients, we got server. We're just going to run a bunch of servers. We're going to have a routing interface. Piece of cake. Let me tell you, super not easy. This thing was the most amazing, rewarding, and challenging engineering project I've ever experienced in my entire life. Getting millions and millions of apps running in a contained, controlled, consistent infrastructure was super fun, but certainly was not easy. Shortly thereafter, April 2008, Google App Engine into the market. February 2010, Microsoft Azure came along, and suddenly we realized we had two of the biggest technology giants were hot on our heels with similar products that hit what up until that point we were the only person in the market, which was had its own challenges of being in a market of one. But now we were in a market of three, but our competition was crazy. That fun story. But long story short, 2011 we were acquired by Salesforce and became the Salesforce platform as a service to compete with Microsoft Azure and Google App Engine. And for all of you out there who are doing the entrepreneur thing, it was a really fun process. We got to go to Dreamforce, and we got to get up on stand up in front of everybody, and for the big announcement of the acquisition, we got to go back to Y Combinator and collect our black shirts. I made something people want, and I'm very proud of that shirt. I keep that hanging on my wall. So if you don't know, they give you a gray shirt when you enter, and they give you a black shirt when you exit, so to speak. And we got to have the joy of being for a couple of years the biggest exit that YC had experienced, which was really it was very humbling. So the cloud. Let's talk about this. This is what the talk is really about. So the cloud leverages huge economies of scales, but it centralizes the internet. You sort of take the problem of running the infrastructure, you push that to a set of experts, allow them to and get those benefits of economies of scale. get those benefits of sort of centralizing the skill pool. And there's huge benefit for doing so. I mean, I don't know if any of you are using Heroku out there, but for those of you who do, it's very, very nice to be able to pump on this problem to someone else and focus on your application, to focus on your business, and it's fantastic. And I'm a big fan of cloud. But the downside is that in a macro view and the big long-term vision view, it's centralizing the internet. It's pushing more and more of the internet into a central place, which are these massive cloud data centers, these Amazon, AWS facilities, the Google facilities. And there's downsides to that. It makes things fundamentally far more fragile. Up until this point, the internet has been a remarkably decentralized thing, where there's no place you could go to knock the internet out. And nowadays, like if you took out an Amazon data center, man, that would knock a lot of the internet out. And there's also other issues, security concerns, Snowden, Prism, Rogue State, lots of stuff where we're basically just we're making it that much easier to monitor and the internet and whatnot. Hey, what about a decentralized model? What about is it possible to do cloud-like things without centralizing the heck out of everything? And generally the answer is no. I mean, the whole point of cloud is you centralize, you're getting those economies of scale. But bear with me here. Let's examine. So I want to take you through a case study of a little app, a little toy app that me and my partner made recently to sort of explore these ideas. And we, in the vein of end user computing, we were looking around at people who were non-programmers but were doing interesting programming work. And in the academic field, there's these IPython notebooks. And I don't know if any of you are familiar with it, but this fascinating tool where basically you run a local daemon, it serves up a web page. You go into the web page and you edit a document, which is a combination of prose, markdown, images, and Python code. And as you can edit the Python code and rerun it, it can generate charts and generate graphs and let you it works like a notebook. That's why they call it a notebook, where you basically put in your thoughts down. You can talk in human text about what you're trying to do, and then you can put down in code what you're actually doing, and then generate results. And it's a really good way to share your idea, to get your ideas down, but also to share your ideas and collaborate with others. But there's some problems with it. You have to install software to get it going. You got to get Python and pip and the IPython server. You got to get all the versions right. Collaboration and sharing is like with a Microsoft doc, where you're going to email the IPython document to someone else, and then they load it up, and their versions might not be the same as you. And there's latency when you're writing the code. You have to type the Python out, and then you got to hit a button to send it to the server to run it to get the results and ship it back. And sure, that's just a couple clicks and just few milliseconds here and there, but it isn't this sort of this zero latency live coding type of experience that I kind of crave. So we were looking around to see what people were doing in this space, and there's an organization called Jupyter. These guys it's a company funded by academia to try to take Python and make it better. And we asked them what they're doing, and we looked at what they're doing, and they're basically going to build this infrastructure, this client-server infrastructure, where they run these giant arrays of Docker containers in the cloud. Each Docker container contains the Python process that's executing the notebook, spin them up and spin them down as they're needed, and they'll let everyone go to one website without having to install software to edit their IPython notebook. And oh my gosh, this is starting to sound really familiar. I talked to them on the phone, and they're like, oh, it'll be easy. We'll just set up all these Docker containers in this router, and I'm getting PTSD flashbacks from all the stuff that we had to go through. And I warned them. I said, listen, if there's a way you can do this without building this extremely complicated server-side architecture, all this cloud infrastructure to do this, you should look into it. But we decided we sort of set out exploratorily and asked, do you need to build this heavy-duty cloud infrastructure for a project like this? And I don't think you do. So there's some, just like virtualization was the enabling technology to kick the cloud off, there's going to be some enabling technologies that sort of allow this stuff to us to move on beyond. And the first thing that we ran into is something that I hope a lot of you are familiar with, which is ASM.js, soon to be WebAssembly. Basically, if you're not familiar, ASM.js is a subset of JavaScript that has very limited capabilities, but is very easy to be compiled down into efficient machine code. And the goal of it is so that you can take a C program, say, run a C compiler on it, but output ASM.js as the output, then run it in a browser and get good performance. And they have like Unreal Engine games and Quake and things like that that can compile to ASM.js and run in the browser, which is amazing. WebAssembly is the soon-to-be released child of this, which is a compact binary format, which will drop the size of the compiled apps by 50 or 60% and radically reduce the startup time, because you don't have to parse 100,000 lines of JavaScript, parse and lex 100,000 of JavaScript in order to run your application. So it's creating this interesting thing where the browser is becoming a valid compiler target for anything. Whereas before it was, you had to use JavaScript to get anything done. JavaScript is going to go its own way. WebAssembly is going to go another way. And now any language, in theory, can run in the browser thanks to this. And you can also think of Node on the server as being able to run these WebAssembly binaries too. And it's kind of fulfilling the role that the JVM and Java set out to do so long ago but failed, which is to create this sort of ubiquitous compiler target that is secure and can run on the client machine or run on the server machine. And we're sort of approaching this interesting world, and the performance is high enough that it is competitive with any other virtualized environment. So there's that. The second one was WebRTC. I don't know if any of you have played with this, but this is amazing. It's this extension to most modern browsers. There's a few that don't, but it's basically Google Hangouts in a box. Google took all the tech in the Google Hangouts, kind of turned it into a standard, and then rolled it into Chrome, and now it's in other browsers. It lets you grab the camera and grab the mic and set up video chat very, very, very easily and circumvent firewalls. So you're connecting directly to another browser without having an intermediary server. And this is the important part, is you're going peer-to-peer, client to client. Now there's a thing most people don't realize in WebRTC, which is that it can do data channels. The data channels are just a way to write arbitrary data and objects to another browser without having to go through the server. And you don't get the annoying pop-up saying this app would like to use your camera, this app would like to use your mic. You can go to a web page, and it can start that connection directly to another browser without even letting you know what's happening. So you get this nice peer-to-peer thing that alleviates the need for the centralized server. So we built this proof of concept app, which is similar to an IPython notebook. In fact, it imports IPython notebook files natively. It lets you edit the prose. It lets you write Python code. But we took the PyPy.js application, the PyPy.js language runtime, and through the PyPy.js project, that gets compiled down to ASM.js, and it gets loaded into the browser. So all this Python is running locally in the browser as you're interacting with it, and it gives you the ability to have live coding. You can type into the browser, and with each keystroke, it's reevaluating the Python and regenerating results. And if you look in the top right-hand corner, you can see there's two little icons there. That's two people connected over WebRTC who are collaborating on the same document. They can make edits. The edits are made on both browsers. The code can get re-executed. The results can get shipped back and forth. And you end up with this. Environment where the browser is doing most of the work now. And in fact, once the document is loaded and once the people are editing it, you can kill the server and the app continues to run. You continue to edit the document, you continue to execute the Python, you can continue to collaborate with other people with no server on the back end. So here's what the traditional version of an app like this would look like. And this is how we've been doing things forever. If you were to build a thing like this, you've got the client, which is responsible for the UI and the text editing, and then the server executes the Python, it builds notebook state, you handle identity, which is logins and passwords and things like account management, delivers the application itself, the JavaScript, to the browser and the HTML. It stores the state of the document, manages the Docker containers, routes connections to the right Docker container with all that stuff. Peer-to-peer messaging between the clients with collaboration as they're editing the document. This is the normal way to do it. Now, when we sort of flip things on its head, it looks very, very different. Now the client's responsible for almost everything. And several things like the Docker management and the routing and the orchestration just drops off entirely because it's no longer needed, making this a smaller project in general. And the only added capability now is that the server is responsible for a WebRTC handshake, which is a very simple process of just letting the browsers send a handshake message and response back and forth to each other as they want to start their connection. So by doing this, you end up with a radically simpler app. And the server side has gone from this big, expensive, complicated cloud infrastructure to a very, very simple CRUD app that basically you just log into, serves up an application, and can save an object. And when you're done editing the notebook, and that's not very much. So this got me thinking, like, what else can we decentralize? Like, we got by incorporating WebAssembly and also WebRTC, we got 60% of the way from a centralized app to a decentralized app. So just a warning, we're going to go into crazy town here. Like, everything from this point on is not like code I've written or engineering or anything that I'm an expert on, but is kind of the mad scientist-y, wild speculation stuff that I like to get into. So I want to, like, imagine what would it take to take this app that we wrote and get it all the way to decentralized, where there's no centralization whatsoever, and what kind of technologies we need to do that. Now, there's a lot of really smart people out in the audience right now, people smarter than me, and I'm going to go through some of this stuff, and you're going to be thinking, this is retarded, Orion, this would never work. I know this is speculative stuff. Please tell me about the stuff that isn't going to work, but I just require include an idea of how we might be able to get it to work. I want to evolve these ideas. I want to kind of push them forward. I want to get more people thinking about them, so we can kind of, see how far we can push this envelope. It may never be possible to get fully decentralized cloud-like services, but I bet we can get pretty close. So let's look at the WebRTC handshake. This is the simplest. Thing to factor out. And again, we're sort of in magical imagining things land here. It could be factored out into a service like DNS. There's nothing special about the handshake. You basically just need a rendezvous point where two or more people can just meet and then trade two simple text messages with each other to give each other information on their IP address and firewall, so that firewall can be routed around. There's also stun and turn services, which help facilitate this, and the turn services being tunneling in case the firewalls cannot be breached. But you could imagine, just like DNS servers, there could be lots of public places where this could be done without any necessary centralization. So, you've got what about the application delivery? Right now, this is you go to the web browser and you download the HTML and JavaScript, and you need a centralized server to do this. But let's think again about WASM, WebAssembly, as being a compiler target. We can kind of think about this like it's a native application. You're building a native application that's going to get served out over the net. HTTP is the way for downloading it now in the case of the web. And if it was a native application, we'd have that app store. So to kind of put that analogy in your head as we sort of thinking about, as you think about it, one of the things you're going to need to do is, for the app store component, is have control over the caching APIs. When do you go out and download a new version of this app? How do you manage that? We're already doing offline apps with HTTP, where you have these cache manifests, which get you about 60% the way there and allow you to write an offline application. And they're working on versions of this, which instead of just a manifest is basically a little blob of JavaScript, which allows you to programmatically write the update policy for the app, when to get a new version and where to find it. And so you can imagine that at some point in the future, if you have a public key identity and a programmable caching policy and the ability to sign code, which is technology we already do for everything not on the web, it'd be very easy to do this sort of thing where you could literally get your application code from anywhere. And it doesn't necessarily have to come from a centralized server. Well, where do you get it from? I'll get more into that later. And where does this public key thing come from? Well, that's part of identity, which is, this is probably the meatiest thing in this whole speculative talk that I want to get into, and the one that I personally am the most passionate about, and I really hope someone figures out. So let's think about identity for the clients in terms of what we do right now at the web. You got a username and a password / account management that you use to make an account and log into a site. And we all know that passwords suck and usernames suck and logging into things suck, and people are trying to fix this with stuff like LastPassword and 1Password, and we're getting there. And there's also OAuth, which I think is vastly superior to managing zillions of passwords, but it's still very centralized. It still requires a centralized authority to manage your identity. And then you got the server component, which the server's identity is managed by DNS. We look up the domain name, DNS tells us where to find it, and then we use certificate authority to sign certificates so that we know we're not getting manned in the middle by an attacker when we're connecting to the correct server. Now, if we're gonna think about a future that's fully decentralized, we're going to have all of these facilities from client to client handled. So we got to cover user identity, and we also have to cover server identity. So I'm imagining a distributed registry of names and public keys that would exist somewhere, and this would be a non-centralized, organizational body managed global database of names and public keys. And if we had it, we could use it for the equivalent of DNS to look up where people are or where people say they are, or where to find the resources, and also access to public keys. So we can, the client can identify themselves, the server can identify themselves, can prove who they are through cryptographic signing of things. And it sounds great, right? But no one's gonna work on something like that. That's crazy talk. Well, actually, there's a bunch of people already working on this. And this is sort of what gives me hope that all this stuff isn't crazy talk. There's Namecoin, which is using blockchain to try to create a basically, they're coming at it from the DNS angle, where you mine out names. Now, and there's also OneName, which is kind of coming at it from the person identity, where you bring your identity with you. And neither of these things have caught on yet, but it's exciting to see that some of the early work is being done. And hopefully someone will nail it, and one of these things will catch on and will continue to grow. And I think a large part of it has to do with the user experience. Now I've always wanted for the user experience of identity to have like a physical key instead of a password for my identity, to have some kind of like physical object that you can use to log in. And there's people working on this too. Yubico makes these nice little dongles, these little crypto keys you can use to do either two-factor auth or to log into sites. And they're fantastic. I use one for my 2FA on Gmail, and I love it. It's on my keychain. And what's this world look like? What am I talking about? Does this still sound like crazy talk? Well, this is where you bring your identity with you. So when you come to a site, I choose to carry my identity to a website when I browse to it. And you never have to go through account creation again. You would show up at a site you've never seen before, and you wouldn't have to create an account, because that site could verify your identity and do whatever allocations of objects they need on the back end to remember you, and for when you come back later, without you having to go through this creation. You show up with your ID card, which I'd love to never have to make an account again. Oh, God, how many times have we done that? And you never have to log in again. You go to a site you've never seen before, and you're already logged in, and as long as you're carrying that identity. You could protect your privacy by having multiple identities. You might have one identity that you're willing to have tied to your factual person, and one identity you're not, which is probably how I'd do it. You could also tie identities to third parties, and this is fun, because you could imagine a situation where you could go to the DMV with your little dongle and use it to authenticate that you're you with your driver's license and your proof of whatever, and then now you get a digital certificate signing your identity from the DMV saying that you're this factual person, and you could use that to pay your taxes and to vote and all kinds of things like that, where one of your identities could be verified by any third party you want for those purposes. And all kinds of fun things start to open up if this kind of identity process existed. So then we get into the final frontier of this talk, which is decentralized state. Now, this is the area where I don't think that we're going to, I don't think we're going to get to this, but it's just for completion's sake, I think we should talk about it, just to imagine what it would take to close this out and to completely remove the centralized cloud. Let's imagine for a minute a magical decentralized publicly writable database, this big amorphous decentralized thing that you can write data into. It's magic, right? Nothing like this exists or probably will exist, but if it did exist and we had identity and we had public keys, then you could write data into this thing as encrypted blobs that can be decrypted by the correct parties. For instance, if you were if doing a social media post, it could be decrypted by your friends because of the way you have it encrypted and signed. And if you were sending a private message, the message would be public, but it would be indecipherable to everyone but the recipient, who would have the key and then could view it. Now, the technology for this kind of thing is kind of wonky, and I'm sure no one's working on it. Oh, wait, blockchain again. There's Bigchain, which is a recent startup which is trying to make a multi-petabyte, highly scalable distributed database based on blockchain. And will it take off? I don't know. Will this solve our needs? I don't know. But the idea is that people are working on the basic technology that it allows you to build big decentralized things like this. And I don't think it's a technology problem. I think that if we were ever to see something like this, where we could have these big decentralized data stores that were to exist, that the primary problem is economics. Who's going to pay for it? In the case of so just imagine for a minute all of your data that you keep stored on free services that you don't have to pay for, like Google or Gmail and Facebook and everything else. These guys pay for that tiny slices of hardware that they need in order to manage all of your data with ads. With you ignoring these little things in the corner of the screen is all it takes to pay for the massive arrays of servers that are necessary to do all of this. In the case of Bitcoin, they convince total strangers to go out and buy tons of hardware and set up giant mining farms and whatnot because they're money, and somehow have got it to work like that. Now, you can imagine some kind of, if someone can crack the incentive structure necessary to get something like the Bitcoin thing to happen, where total strangers who don't know each other are going out and buying big arrays of servers to set up this public infrastructure, they would start to build this infrastructure out and have incentive to do so. But we must have something more valuable to offer than our inattention, which is all we're giving Google and Facebook to pay for those giant racks of servers. You know, we all have bandwidth, we have CPU time. Like what are other things that we could figure out to monetize to build this kind of thing? So you can imagine a world where if you were to go out and buy a ton of infrastructure and set up to add your computing and storage and bandwidth to this global data cache, that you'd be making, say, cryptocurrency or something like that in exchange for that, instead of just doing what we're doing now with cryptocurrencies, which is generating lots and lots of heat. So it's a crazy idea. I don't think we're going to crack it, but again, I think the technology's there. I just think no one's figured out the economics. So, anyways, that's my grand idea. So for what a post-cloud world might be like, I want to encourage you guys to look at things like WebAssembly and contemplate how you might be able to make your apps simpler by pushing more of the weight of it out to the client to sort of put less reliance on the centralized on the center part. You might be able to make your infrastructure much simpler, might make the operational burden on yourself much less, and might help discover some of these edge technologies and help push them forward and help refine them and think about these problems. Because I'm hoping that at some point in the future, especially the identity and many of these other problems can be cracked and we'll get to a point where we can have all of the benefits of cloud without necessarily having to massively centralize everything at some point in the distant future. So there's the GitHub link there is to the actual Python in the browser application that I showed, in case anyone's curious to look at the code. There's the WebRTC stuff is in there, and the PyPy.js compiling and running the Python code is in there. If anybody wants to ping me, there's my Twitter account. And that's everything. Thanks, guys.
Orion, thank you. That was a great presentation. I learned a lot. Thanks so much for that. And as you've been chatting, we've been actually polling the audience and asking them a few questions. And also, they've been asking you questions. So let's go to the audience and see what the audience has to say. So first, let's go to the polls. So I was kind of curious about how our audience is composed in terms of their relationship to platforms like Heroku. So we asked them, first of all, do you use Heroku? And about 30% of the audience does use Heroku. And in fact, there's about twice as many audience members, according to our polls, that use Heroku compared to writing apps directly to AWS. And so they really do like the Heroku paradigm. And so I think you've done a great service for our audience to make such an accessible deployment environment for our audience member. So I want to thank you on behalf of our audience for that. This is, I love Heroku. I use it all the time, and I owe you a debt of gratitude for that. So thanks.
Well, it's funny because like I hate sysadmin DevOps. Like I hate it with a passion. Like when I was running my previous businesses and I was on the floor of that colo facility at 2 a.m. with that burnout motherboard, I was just like, God is my witness. No one will ever have to do this again. And then I went and started a business where I was doing this for a living for 7 years. Oh my God, what was I thinking? But it was my hate. It was my hate for that kind of thing that drove me forward, because I wanted to spare all you guys all that pain and suffering. I wanted you to be able to deploy your apps without having to manage all that stuff. And there's, obviously there's a lot of good ways to do it. There's the Google stuff, there's the Microsoft stuff, there's AWS, which is fantastic. And if you guys are getting value out of Heroku, thank fucking God, you worked hard to try to make your life a little easier.
That's great. A lot of the entrepreneurs that I've met start the same way, and a lot of open source developers where they're starting by solving a deep pain that they have that they're frustrated with. And in fact, a lot of the villains in today's world also started from solving something they're really angry about. But luckily you're not a villain. So
thank goodness. I think most successful businesses come from a point of pain. And this is one of the areas when I'm sort of talking to people who are want to get into entrepreneuring, and they think, oh, be an entrepreneur, and I see a market opportunity over there. I'm like, but have you suffered in their shoes? And it's usually, well, no, I just sort of did some market research and I think I could. I'm like, I'd say like 80% chance you're going to build the wrong product because you don't have that experiential pain. Like for people in that situation, I really do think like you will save yourself time and money. Like, and this is kind of an extreme thing to do, and maybe it's not the right thing in most situations, but it would, if you like went and like worked in the job that you're trying to build the product for, like pushing the button that they're doing and suffering with the stuff they're suffering with for a couple of months before building your product, like you'll knock years off of the runway between when you start and when you're going to be successful, because like you've suffered that pain. You had those bits of glass driven into your hands by the misery of whatever market it is. So the best companies come out of places where you were suffering and you're like, God damn it, someone needs to make a product to solve this. Anyway,
you're allowed to swear, by the way.
Oh, good. I didn't know that. There might be kids out there.
So yeah, we're trying to make it a raw conference. So anyway, so I agree with everything you just said, by the way, and I do think that entrepreneurs who solve a deep pain tend to be more successful. I've actually noticed the same thing. I also noticed the same thing in the open source space, for developers who are solving a personal itch. In fact, Brian Fox was just referencing that in our previous chat. He said almost the same advice that you just said. So let's go to some of the audience questions. So the first question with the most votes, 248 votes, is how often does a programmer need to change jobs? This is actually a pretty interesting question because some people are kind of worried about their resume and what does it look like and all that stuff and their career path. So any advice or thoughts on this subject?
That's interesting. I don't have any super strong feelings on that. Obviously, if as a person hiring, if you see 5 jobs a year on someone's resume, you're going to assume that they're pretty schizophrenic and they're not going to stick around. And if you see someone who worked for 25 years in the same place and doing the exact same thing, you're going to worry that their information is way too siloed and way too narrow, and they don't have a big enough breadth of experience to take on what you want them to take on. So I'm sure there is an error on both ends of that spectrum. But I sort of beyond those two extremes, I don't think there's necessarily a right or a wrong answer to this. If I think it's far more important that wherever you are and for however long you stay there, that you're getting a very a quality environment that is helping you develop yourself as a developer and become better at what you do. If you're at a job where you get to learn the skills you want to learn and get to work on a variety of projects, and a lot of this can be just solved by, say, moving from team to team, within your own company every year or two, to get, you might be on the sysadmin team one year, and you might be on that application development team another year, and you might be sort of like a sales team tech assistants another year, and get access to lots of different skills and lots of. It's just all that matters is you keep growing. There are situations where you might be in a job where your field of work is so narrow you're not getting to grow. Like if you're the kind of person who comes home from work every day and you've got this long list of personal projects you want to take on because none of your technical personal itches are being scratched at work at all, but you're can't get around to them because it's so hard to do personal projects and this is just going on and on, it might be time to change jobs to something that's more aligns with your actual interests to help you grow in that area. Because, you know, passion and interest is so tightly aligned with being successful in general. And there's also situations where you might be at a, you know, a dead end job that's you know, not paying you enough, and you got to jump jobs to get a raise in some industries. You know, I think at least in the Bay Area, most developers seem to be pretty well paid, depending on the situation. But there are lots of times where this happened to me a lot early in my career, and I'm sure it happens to everybody else at some point, where you get a job, you ask for a raise, and they're like, no, but you know, the guys across the street want to hire you for $20,000 more, and that's great. Now it's time to move. You know, that just answered your question. You gotta manage your career. But yeah, I think it's just all about having you know, you don't need to get replanted so often. You just need nurturing soil to put down roots in and grow. And if you can find that space, stay as long as you want. And if you can't, keep moving.
Great answer. Okay, so let's just take the next question here. So what are some new trends and architectural patterns being used on Heroku apps?
I've not been plugged into the Heroku ecosystem for 2.5 years now, since when I left the company. So I apologize for not being super up to date on that. But I know they did the development pipelines recently, and we built a Heroku app for this the project that I was talking about in my talk, and I got to use those for the first time, and that's a big relief. You know, getting to push to GitHub and have yourself auto deploy from there, and then be able to manually promote to production when you're ready to go, and it's a nice workflow. It's better. I hope that the guys at Heroku take my advice and do tighter Docker integration in the near future, because I like Docker containers and the other various containerization technologies, and I don't see any reason not to treat those as first-class citizens. That also opens up the door to all kinds of fun things that I hope end up on the Heroku platform at some point, such as getting sort of more bare bones virtualization containers instead of just the web app containers. I'd love to see all of the add-on providers running on Heroku, because we offer a good abstraction over AWS. And then I'd love to see Heroku and other substrates other than AWS. You know, why not? I should be able to just drag my app from US East and put it in the Google data center, or maybe drop it in Ireland and have everything just magically update. And all my add-ons can follow me because they're written to the Heroku abstraction and not the AWS abstraction. So spinning them up in an alien data center they don't know anything about is a useful possibility. I mean, these are things that have been on the wish list for a really long time. And again, I don't have any transparency into what they're working on these days for the last 2.5 years. But you know, those are at least the infrastructural patterns that I have seen and hope to see for cloud providers in the future.
Okay, great. And we'll take one more audience question based on democratic voting here. If you were starting out today, what would you build? So, you know, maybe some other spins on this question could be, what are you working on right now? What programming languages are you using? And maybe what are some lessons learned for how you built Heroku that if you were starting out today, you would have done differently?
Oh, well, I mean, those are a bunch of different questions. What am I doing today is kind of a different question from what I would do if I was starting out, largely because, having Heroku in my past, I have the luxury of being a lot more egalitarian about the kind of stuff that I want to work on. Like 9 years ago, if I was starting a project from nothing, like the number one item on the to-do list is like, is this going to make a lot of money quickly? Because if the answer is no, I'm going to starve to death. And that radically narrows the type of projects that you can choose from. And whereas, like the stuff we were doing, this product that the demo that I included in the talk was something that my partner and I built because of intellectual curiosity about places for people to code and ways to deploy apps that allow you to code in the browser. And I don't know if a business could come out of it, and if it could, how successful it could be. But it's one of the luxuries I can enjoy right now, which is to scratch the intellectual itch instead of the I need to make money as quick as possible itch. But what I do right now, man, this comes back to the experiential pain thing, which is there, like, okay, just this is an exercise I encourage for anyone who wants to figure out how to start a business. Just close your eyes and imagine the world is perfect. Everything in the world is perfect. There are no problems that need to be solved. Now open your eyes and look at the world around you, and all the differences are business opportunities. Every single difference between that imagined perfect world and now is something someone's got to fix. And if you can find a market incentive to do that, where people are willing to pay to help you fix it, that's a business opportunity. That's something you can go for. And if it's something that you're familiar enough with, where you experience the pain, where you would be a customer if the opportunity arose, I would do it. Now, as far as like my experiential pain back in 9 years ago when we started Heroku was based around the crappy DevOps situation where that everyone was in, and wanting to make that situation better, and also with the higher grand audacious goal of wanting to help make coding more accessible to the world, to try to get a larger percentage of the population writing code. And we thought that like cleaning up the deployment and server story would lower the barrier of entry and let more people into that crowd. So I think it's good to have a big, hairy, audacious goal, a big, grand vision of how you want to make the world a better place. You have to be pragmatic as well and know where your market is and where you're going to make some money. And you got to have that experiential pain of what you want to solve. Now, if I wouldn't make Heroku today, I wouldn't make probably a cloud service today, because I think there are tons and tons of really good cloud services that are out there, and sort of the customer, which is in that case the web developer, is being very well served now, whereas they weren't 9 years ago. They're being very, very well served, and I'm generally personally more interested in markets that are underserved, finding people that are neglected by the current state of affairs, but need whatever tool it is that I can make. So that's for instance like where going after scientific academics was sort of like the target market for that thought experiment that we did, because the programming and development tools in that area stink. And in fact, most areas that aren't like core programmers, the kinds of tools that are made available to them are pretty terrible. So I could, follow on with my experience of making tools, but try to do so to serve an underserved market, a group of people. And I also like the idea of building things for academics, because if I can make them more productive, maybe they'll solve some more of the world's problems because they got better tools, and that's good for everyone. You get the positive knock-on effects there. So yeah, like if my wife works in medicine, and she I get to look over her shoulder and see all the terrible software in healthcare, and I wouldn't want to jump into that unless I had personal experiential pain of that. But every industry you peek into, you're going to see just terrible tools that desperately need to be replaced. And if there's a channel to get into that market and to sell this tool to the people who need it, which there may not be in medicine, for instance, because of all the stupid regulation, take it, solve that problem, get that product to market, and see what you can do. So I don't know, that's kind of my brain dump on where I would go and why, or at least how I would elucidate that decision of what to build and for who to build it for. And if you've never experienced pain and you don't know of any problems to solve, just live a little, and by this time next year, you'll be super, super experienced on something painful and know something that is imperfect that needs to be fixed.
Great answer, Ryan. Thank you. I've got a couple of questions of my own that I'd love to chat with you about before we go here. So I'm curious about kind of the background of Heroku and the story for how you originally started that product, and as well as what it was like in the early days. Like, what did you guys struggle with as an entrepreneur back then?
Oh man. There was stuff that predated Heroku. Adam, James, and I, the guys who founded Heroku, we were working at a software consultancy in LA. This software consultancy is a funny story, because basically we wanted to start a company. We didn't know about VC, and we didn't have the cash to bootstrap it. So we were doing consulting on the side, and this is a quagmire we wandered into that I'm sure many people in the audience have wandered into, which was we're taking consulting work in order to make the money to work on passion projects that we wanted to turn into companies, because we had to eat. But the consulting projects always took up all of our time. So we started hiring guys to do the work for us so that we could focus on the business. And fast forward 2.5 years, we had 25 engineers working for us, and like, a dozen big clients that were always knocking on our door for more work. And we still didn't have any time to work on the product. because we were busy running a consultancy business. And you know, you'll run into a lot of people that say, don't try to consult to pay for your business. It's better to sleep under a bridge and eat ramen and focus on the business completely than it is to try to have your cake and eat it too, because that will eat up all of your time. And that's where we were. We were kind of caught perpetually in this consulting business, but we were doing little projects to try things out. And one of them was a little proof of concept that Adam threw together, which was basically a in-browser Ruby debugger. It was a combination of sort of writing a thing which would let you view this Ruby source code. It was a plugin for Mongrel that would grab the Ruby source code and serve it up into a view inside of the browser, plug into the Ruby debug and give you like highlight the line and let you step over and trace and things like that. And it was kind of hacky, but it was really cool. Like as soon as we saw that you could do that, go to a web app in the browser and then pop into a debugger in the browser, we're like, oh, this is sweet. And this sort of got us working down this line. Then we went to RubyConf, and then that's when we had that sort of revelation of like, holy smokes, all these guys at RubyConf are not the normal like lifers that have been coding since they were 6 that we run into at most of these conferences. These are people that as adults picked, and after having other careers, picked up programming, found they liked it, and started making stuff. And we'd never seen that before. So we were like, wow, like something like if Ruby is 3% more accessible than the last thing, that 3% must be a breakpoint where a significant chunk of the population couldn't grok it before, but they can grok it now. Let's try to figure out what's stopping these people from being more successful and fix that problem. Because with the grander idea of trying to get more people programming. And that's what led to everyone, we would talk to these people and they're like, yeah, so I've got it working, but now I need to get it on the internet, and I've got mysql.tar.gz sitting on my Windows desktop, and I don't know what that is, but I'm pretty sure it's important to get this application running, and I don't know what to do next. So after hearing that story 100 times, we're like, okay, well maybe we could just make a website with a button you press to make the app, and that's how that whole thing got started. And the code editor in the browser was a descendant of the in-browser debugger that we had made 6 months or a year earlier as a proof of concept. We ended up disabling the debugger features because we couldn't get them working, and we figured we'd add them back later. But then sort of the big challenge happened, which was changing markets. This was the whole pivot thing you always hear startups talking about. We didn't know what a pivot was at the time, but we just knew that suddenly a new group of customers came in and were using our product. And these are the guys that I mentioned in the talk who were uploading their apps as zip files and running their business off of our code editor without ever using the code editor, which was the product. They were just sort of, using us as a hosting service. But why would they do that? Apparently, there was value in this hosting part of it, but we weren't, the applications were running in development mode, and there was only a single one, and they had a small amount of memory, and they weren't really designed to run a production application on. So we started to basically build 2 businesses at that point. We split our efforts and continued to work on the code editor and the development tools, and then tried to make the system more robust so that it could handle real production workloads and run the code efficiently. And we sucked as soon as we started doing that. The quality of product started to diminish. Our uptime dropped. The number of bugs went through the roof. We had a couple of moments where we were like, this is never going to work. We need to just pack it up and go home after like some especially embarrassing outages. And we were too little butter spread over too much bread. And this is when we kind of had our come to Jesus moment where we sat down and talked about it and said, we got to pick a market. We got to either serve the people who are learning to code in the browser, or we got to serve the people who are trying to run a real app on our platform. And then we need to cut the other one. And God, I tell you, that was the hardest decision we ever made in the business. And it was the one that almost killed us because we delayed making that decision for 6 months. And the business came very close to being destroyed by our inability to cut something we loved, because the code editor was what we loved. It's why we got started. It's what brought us to do this. We wanted to bring coding to people. And when we finally did it, we broke it into 2 products, and we basically ran Heroku Garden as the editor and basically said, this is unmaintained, put your stuff here if you want, but it'll probably break. And then our primary product, which was the Git push to deploy, that had no code editor, and it was one mode only, which was production and scale. And that's when we stabilized, because we could throw 100% of our effort behind a very narrow product, make sure our uptime was good, and make sure we could scale, and make sure we were fast enough, and sort of let our baby die on the roadside so that we could continue forward. And that was one of the big, hard early choices that sort of shaped my thinking about this. And this is where, and this is where when I'm giving advice to a lot of people with startups, everything's a balance. Like there's very few things that are true virtues where you just want to max to 11. And I sometimes see people saying, pivoting, that's a virtue. We're going to pivot 3 times a day. And obviously you're never going to have a business if you're pivoting 3 times a day. You want to do it only when you absolutely need to, but you got to pay attention and realize when you're barking up the wrong tree, that when you're in the wrong market, and notice that there's pull coming from another market where people who didn't intend to build the product for are wanting a slightly different product, but they want it so badly, they're willing to use your gross approximation that's marketing to an entirely different set of people, and be willing to pivot when you need to, and be willing to like cut off your arm to keep going forward because you've invested all this time and this energy in a product that might be the wrong one. So pivoting is important. Pray you don't have to do it, and don't do it unless it's an emergency. But you gotta pay attention to your users, and you gotta pay attention to the market, and know when you're in the wrong one. So
great answer. That's a great answer, man. So we only have about 60 seconds left.
Okay.
I want to just squeeze one last question in there. If we get a fast answer for this. So one thing I've noticed is that there are some development teams that are too big for Heroku, but too small for AWS, meaning they don't have enough DevOps budget or time or expertise to build that whole team to do their own DevOps. And they really like Heroku. They love the simplicity of it and all that, but they want to have a little bit more control over things. So any advice for startups or organizations that are in the middle there?
Oh God, holy crap, yes. I mean, well, the advice I have to give is actually to Heroku, which is to find those guys, those teams, and reach out to them and work with them, because one of the missing, I think a lot of the missing features in the Heroku ecosystem involve kind of those enterprisey features that sort of allow larger and larger teams to work effectively with those apps. And Heroku as a company desperately needs to better understand these people. The way we used to describe it for Heroku was that we were building this ramp, and if you were like, when we first built it, it was a tiny ramp, and if you were at 0, 1 person just trying to get going, it was the perfect little ramp for you to drive up to get a little higher. And as we built the ramp higher and higher, and at some point people would get so large that they fly off the end of the ramp and they have to go crashing into the ground and try to have to go the rest of the way on their own. But what you're describing is a chunk of the ramp that hasn't necessarily been built yet, and I think part of that is coming from a full lack of understanding of exactly what these organizations are going through and what their needs are. And anyone who is in that situation, I encourage you to reach out to Heroku and let them know you're willing to share your needs with them so they can help guide the product. And I sure as hell hope the guys still at Heroku can reach back and talk to you guys and learn, because when we first built Heroku, we were building it for ourselves. We were building it for the teams that we had run and the products that we had built, and we had that experiential pain. And as the product grows, we get further and further away from our experiential pain, and further away from, because from what we know, then we have to start relying more and more on other people's experiential pain in order to continue to build the product out. And we can't know that unless we've met the people that experience that pain and learn from them. So yeah, please reach out and hope that they're smart enough to listen. And tweet me if they're not, and maybe I can tweet some nasty things at them. But yeah, that it's that information that you have that they don't, that is what's necessary for a product like Heroku to continue to grow and continue to stay relevant for people as they grow larger.
It's a great answer. Well, thank you, Orion. Really been a privilege to have you here today. So audience,
thank you so much.
Yeah, great. Audience, if you enjoyed what Orion said today, I'd encourage you to consider making a contribution to one of our coding nonprofits. Again, it's all voluntary, but we definitely appreciate it. That's kind of our philosophy here is we try to pay it forward with this education, and then hopefully people reciprocate, and we can make a difference for nonprofits around the world. And then also, we'd love for any involvement in our Hack Guides project to help bring knowledge to the world into other spoken languages. And so, feel free to click on the Hack Guides button to learn more about that project. And Orion, thanks again. It was a great talk. Really enjoyed learning from you. So thanks again.
Yeah, thanks, man. Yeah, good talking. And good luck.
All right.
Have a great rest of the conference.
Guys, we're going to be back in just a few minutes with Dries Bayatart, who is the creator of the Drupal CMS. So this is going to be a very, very special fireside chat between myself and him. So stay tuned in. We'll be right back.